Hello?
Hi, Joe. Bill Fagey.
Hi, Bill. What's up?
You've had experience working in Africa, right?
Right.
So I'd like to know whether you'd consider heading up a program to study a new disease in West Africa.
What's the disease?
Lassa fever.
Lassa fever?
It's a nasty virus, lethal for many people. We need to know what we're looking at here, what's causing it, how fast this thing spreads, how many people it could potentially infect, and how we can stop it.
When do you want me to go?
Now.
It didn't take long for my new boss, Dr. Carl Johnson, who was Chief of Special Pathogens from the Centers for Disease Control, to find out that I didn't know anything about viruses, but I did know a lot about Africa. I knew my way around a laboratory, and I knew a fair amount about computers. So in March 1976, I found myself on a plane with Carl Johnson, heading towards Sierra Leone in West Africa to investigate Lassa fever. Little did I know that it would be start of a long career for me, hunting down and fighting some of the most interesting but dangerous infectious diseases on the planet.
We got the interview with Dr. McCormick,
The
epidemiologist. I got his name from Dr. O'Queeson. I have a feeling he's going to be perfect for our story on the outbreaks of infectious diseases.
Do you think he'll be able to give us a hook for a story?
Yeah, I have a feeling he will. Actually, I knew Dr. McCormick was going to be perfect for our broadcast feature at Lincoln High. After all, this is a man who had probably stared death in the face on more than one occasion in his life.
Hi, Alex. Working in Africa really appealed to me. I had been a school teacher in a small village in the middle of the Congo, and while I was teaching school, I also worked at a local hospital that was next to the school. And so I did all this before I went to medical school. So the idea of returning to Africa and working in the field, working in the population there really did appeal to me.
What's an epidemiologist?
Well, an epidemiologist is a bit like a detective, except they look at diseases, and particularly they're often called to any place on the globe to try to solve an epidemic. And an epidemic is usually caused by an infectious disease, and often people either don't know what the cause of the disease is or they don't know where it's coming from. So an epidemiologist's job is to help sort that out, figure out not only what's the cause of it, but how's it being spread, and hopefully how to stop it.
So where do you do most of your work?
Well, epidemiology often involves both laboratory work and work in human populations. You're trying to solve a problem of an infectious disease, an outbreak in a human population, but it also often requires a laboratory because you have to culture bacteria, you have to grow viruses, you have to be able to identify what the cause of the outbreak is. So I end up working in the laboratory part of the time, but spend a lot of my time working out in the field among people wherever it is the epidemic is occurring.
But how do you know where to start when you get to a new location? I mean, it seems like it'd be pretty crazy.
The basic issue you're trying to figure out is what is the disease and what's causing it, and more particularly, how is it spread? So in order to do that, you have to go out and ask people questions about where they've been, and particularly trying to learn how people might have gotten exposed. Did they eat something that might have given them the disease? Or were they in contact with somebody who was ill? If you're looking at a really deadly disease, like Lassa fever or Ebola, then obviously time is of the essence, and so you want to get to the bottom of the problem as soon as possible.
What kinds of things have happened to you when you tried to do your work?
All sorts of things have happened. I've been in Land Rover accidents, like the time we were chasing Ebola in northern Congo and up in Sudan, and our Land Rover turned over when the driver hit a slick spot on a muddy road, and we had a 50-gallon drum of fuel in the back of the Land Rover, so that was not very much fun. There was a time when we were in Sudan chasing Ebola again, and I managed to, while I was taking blood from an older woman who was quite ill, and it was at nighttime, so we had somebody kneeling down with a lantern next to me because I didn't have a flashlight, and stuck my finger with the needle after it had been in her arm. There was a time when we had a nurse who was very ill in Sierra Leone, where we were studying Lassa fever, and we had to evacuate her. And that meant we had to get helicopters and get people from the UK and all sorts of things. So a lot of different things can happen when you're doing these kinds of investigations.
What causes Lassa?
It's a name given to a virus that was first discovered when people got the disease in Nigeria. And the virus is carried by a very common rat called Mastomys natalensis.
A what?
We did a study of these rats around people, and we found they really like to live around people because they can get food and water. And obviously this increases greatly the opportunity for people to get infected. So one of the programs that we had to initiate was educating people about how to keep rats out of their food and to try to train them not to catch rats and eat them.
But how does the virus get from rats to people?
Well, you know, we're working in a really poor population here. If you just visualize a typical house in this area, it's a mud floor and often mud walls with a thatch roof, no screens in the windows. It's very hot. People often don't wear shoes, and so they will work outside barefooted, and the doors are open most of the day, as are the windows. And so the rodents that like to live around the house can move in and out of the house as they wish. Sometimes when people leave the house during the day, they close it all up, which allows the rodents to run around inside the house as though it were nighttime. And so the rodents urinate on the ground, they urinate on the beds, they can urinate anywhere. When people come back in the house, then they get in contact with the urine, usually through cuts and scratches on their hands or on their feet. And this results then in their increased opportunity to get infected from the virus through these cuts and scratches. So we think that's the way they typically get infected. And then, of course, they can transmit it sometimes to other people in their families. So one of the things we have to do is to teach people how to keep the rodents out of their houses and how to particularly protect the food supplies in their house.
So Lassa fever spreads from rats to people?
Yes, that's one way it can spread. I've already described how that might happen, but it can also spread from person to person, especially in hospitals. And in particular, it can spread to people who are taking care of other patients. For example, nurses in hospitals sometimes get infected if they're not protecting themselves, or if the person who's infected is still at home, often it's a family member who's caring for that person who's ill who ends up getting infected from caring for that person. In our field research, we needed to figure out what was increasing the spread of Lassa fever and how many people actually had it. We had to find out, could Lassa fever spread to countries outside of Sierra Leone and other places in West Africa?
How did you figure out how many people had Lassa?
First, what percentage of people have antibody in their blood indicating they have previously been infected? We call this antibody prevalence. Second, we ask what is the rate at which new cases of this infection occur over a certain period of time. We often use a year, and we call this incidence. So we collect both prevalence and incidence data to look at the outbreak of the disease. Our problem was to calculate either the prevalence or incidence of Lassa fever. We needed to know how many people were in the population. But in Sierra Leone, the government hadn't conducted a population census or an official count of the number of people living there for over 20 years. We were going to have to do our own census. This meant we had to go from house to house in our chosen villages and count how many people were living there.
That must have taken a while.
It did. We had to go from house to house, but we got some surprises, which ended up making the time longer than we expected, because we found houses where there were an awful lot of people in the house, and we weren't prepared for the numbers of people we found in some of these houses. Sierra Leone is a hotspot in Africa for diamond mining and hunting. Those who'd worked in the mines lived in these villages, as well as fortune seekers who were chasing diamonds to escape poverty. What we found in the houses near the diamond mines was really shocking. We found about 40 to 50 people living in one tiny, cramped house. In fact, the only way this was possible was that the miners worked in shifts and took turns sleeping wall to wall on the floor. So guess where we found the highest rates of Lassa fever? In these crowded houses, the disease spread much more easily. And to make matters worse, some of those diamond hunters weren't staying put in a single village. If they heard there was a promise of more diamonds down the road in another village or another area, they would leave quickly. Makeshift villages became ghost towns overnight. The possibility of spreading Lassa fever to new locations became even more of a reality as people moved around chasing diamonds.
So what happened next? How did you stop Lassa from spreading? Is there a cure?
Well, there's a lot more to this story, but before we move on, I suggest that we talk to somebody else who was involved in this, and she has more stories to tell, and that's Dr. Susan Fischerhawk.
Do you know how we could get in touch with her?
Let's see. I think I know her pretty well. Actually, she's my wife, and I think she's home now.
Who would have thought we would be able to find two world-renowned epidemiologists like Doctors McCormick and Fisher-Hawk right here? Where there are mysterious viruses, there is bound to be drama, suspense, and maybe even a little danger thrown in.
Strange things started to happen. First we found one case, and then another, and then a few more. And then more people got sick. We were finding people who'd come into the hospital with one disease were getting this other disease. Eventually we found 12, and 4 of these people would die. What was the culprit? Legionnaire's disease, caused by a pathogenic bacterium called Legionella pneumophila. Legionella had caused a mysterious outbreak of fatal pneumonia in Philadelphia a couple of years before in 1976. Now we were finding it in England, right across the Atlantic. So I had to become a detective pretty quickly, which meant a crash course in hospital engineering, about which of course I knew nothing. I found myself going to a weekly engineering meeting and learning about valves and pipes and the way water flowed backwards and forwards in hospitals.
What does plumbing have to do with Legionnaires?
Well, that was the question. The American studies had shown that they thought that it came from air conditioning systems. So we went round our hospital and it was cold and pretty damp, and we looked for an air conditioning system. We couldn't find one. In England, you don't have air conditioning systems, so we had to look for somewhere else. Before that, we had worked in Oxford with one case, and we had found the Legionella pneumophila in a shower, the shower that the patient had used to become infected. So we decided we'd have to turn our attention to the water system in the hospital. So what I had to do was work with the hospital plans, and to help me, I had an engineer, David Harper, who was absolutely terrific. So he helped me understand all this, and we tried to identify those places in the hospital we thought bacteria might grow. And if I really needed to know something, I said, David, I need that. And he'd crawl into holes and down pipes, all sort of stuff, and get me the specimens I needed.
So you had to test the whole plumbing system?
Well, not the whole plumbing system, but parts of it. First problem was that the plumbing wasn't built like the plan, so we had to follow the pipes and see where they actually went. The big problem was that in order to grow the bacterium, we had to get 24 gallons of water per sample. That was so heavy, we couldn't carry it around unless we stole a wheelchair from someone. So we would go into radiology places, steal a wheelchair and go zooming off down the hallway with nurses shouting after us, "Bring back that chair!"
How did you find out where the disease was coming from?
Well, we had to have a piece of luck, which in fact was bad luck, because David, who was working with me on the plumbing, fell ill and was taken into hospital with pneumonia. And it looked like Legionella, though we weren't absolutely able to prove it. Anyway, we gave him some antibiotics and he did get better. And while he was convalescent lying in his bed, he thought to himself, you know what I did just before I got sick? The nurses shouted at me, "We need more hot water." Well, you have to know the hospital had turned the temperature of the water down to save money. So the water wasn't coming down very warm in the wards, and the nurses would run it and run it and run it and say, "We want more hot water." So to produce more hot water, David went to the engine room where they have what they call calorifiers, these great big tanks in which they boil the water. And one of them was stagnant. It was just sitting there idle, and he switched it on. And that was just before he got sick. So he thought about this and wondered whether that might have been part of what had happened. So as soon as he was well enough, he went back down to the calorifiers, and there was a third one. And this one was empty. It was down for servicing. And when he looked inside, there was this kind of gunky sludge at the bottom. So he scooped some up and took it down to the lab, and we processed it, and it was stuffed with Legionella pneumophila.
Well, how did you stop more people from getting infected?
Well, that was our first task. We had to make sure we prevented other cases. The two ways that we can kill bacteria, one is with disinfectants, another with heat. So we tried both. With the cold water, of course, we couldn't heat it. So we chlorinated. We put chlorine in the cold water, which was more chlorine than you normally get in your drinking water. But we had to make sure it was safe. But we've reckoned the hot water was really where the problem was. So what we did is we said, let's just jack up the temperature and heat it. So we heated it up to about It was about 50 degrees, much hotter than it had been before, and that worked. We couldn't isolate the bacterium any longer. But the funny end of the story was that the engineers came back after about 4 or 5 months and said, you know, by running the temperature hotter, we actually saved money because the nurses aren't running it now to see if it gets hot.
Case solved.
So that helped me in my career, because then what I did is I used this for my doctoral thesis for London University, and I got that and then worked a few years in virology and found myself in 1986, 1st of January, leaving for the CDC. By the time I arrived in Sierra Leone, Joe and his colleagues already knew that rodents carried the disease, and they had set up many educational programs so that people learnt to keep their food away from the rodents, or the rodents away from the food, and stressed they shouldn't handle and eat rodents for food. We set up some parades with giant rodents in which everyone in the village would see a larger-than-life image of the animal that was carrying Lassa virus and showing them what to do about it. Music played a part, and many of the people recognized our Lassa Fever project logo and sang to us, "Lassa Fever no goodo," whenever we passed. The word spread about ribavirin too. We would arrive in places where we were met by people asking, "Where's the ribavirin?" Often they would say, "You got the medicine?" This was the drug that could actually help many people recover after they had gotten Lassa fever, especially if we could give it to the patient early enough.
Hey there.
Hey.
Hey guys, good to see you again.
You too.
So are diseases like Lassa pretty much taken care of now?
For Lassa, there's no vaccine, and there's still no system for treating people with the disease. So it's pretty much the same as we found it many years ago. Ebola, very similar.
That's so sad. I guess we're lucky here in the U.S. We don't have to worry about big fevers and epidemics here.
That's not true. We do have to worry about those things. The world's changing, and a lot of things are happening that we need to pay attention to.
What do you mean?
Well, there are things that we tend to ignore. For instance, in Sierra Leone, which is the country we're talking about, there were 10 years of civil war, and that has very much exacerbated Lassa fever. There's more there now than there was before, and we've done nothing about it. We also have to worry about changing climates and other things that will allow people to get on an airplane, maybe come to the United States and bring these diseases with them.
You mean like a long time ago when the European settlers brought smallpox to the Native Americans?
Well, it's more than that. They brought yellow fever as well. And we have to pay attention because recently we've had West Nile virus arrive recently in the United States, and dengue is making its way into Central America and now into Texas. So the viruses will move if they have the opportunity, and most infectious diseases will.
Like when someone's infected with a disease from another country and then they fly back home?
We do see this happening, and the more travel we have and the more opportunities that people have to encounter some of these diseases, the more we're going to see this.
I remember this man who had probably gotten some really rare TB from someplace outside the U.S., and then he flew back to the U.S. from Greece, exposing a lot of people.
Well, you know, I think that we have to put this kind of issue in perspective. First of all, about 1/3, that's about 2 billion people on the planet, 1/3 of the people are in fact infected with tuberculosis. Now, not everybody's active disease. As it turns out, this fellow actually wasn't infectious and wasn't going to put people at risk. But given the fact that 1/3 of the globe is infected with tuberculosis, it certainly could occur, and probably does occur from time to time, that people get on the airplane, they're infected with TB, and they come to the United States, and they may or may not be detected when they come here.
Is that the only way epidemics can happen?
No, epidemics can be introduced by people coming here. Epidemics can be introduced by animals being brought here. Look at what happened with monkeypox. When animals were brought from abroad and put into pet shops here, suddenly we discovered there was this viral disease that we'd never seen before, and in fact the cause of it was these animals that were brought from Africa, put into pet shops, and they had monkeypox.
But can epidemics like this actually hit the U.S.?
It most certainly can, and it certainly has done. We mentioned yellow fever before, but don't forget the 1918 epidemic of influenza just after the Second World War, where enormous numbers of people were infected and large numbers of them died in Europe and in the United States.
How did it spread?
We're pretty sure of how it spread in the United States, and we think, because this is what usually happens with flu, that it started in China, because that's where most flu epidemics come from. We didn't really notice it till it got into Europe, and I think that was just observation, because we didn't know what was happening in China. What was very striking is that after it reached the United States, probably with the military coming back from the war in ships, because it started in the ports, it spread across the United States in just 4 weeks.
Well, you know, it actually infected 28% of the American population at that time, and it killed more people than were killed actually in the First World War.
Yes, but this, for virologists, looking back, was really what started us thinking, how could we prevent this, and whether could we, in fact, make a vaccine to prevent the influenza. Nothing could be done at the time because we had not invented tissue culture, which we needed to do that. But later on, we were able to get to the point where we can make a flu vaccine.
But that was a long time ago. Could that sort of thing happen today?
Epidemiologists are worried because in spite of all our recent medical advances, changes around the world today could actually result in tragedies like this becoming more, not less likely.
But how?
Scientists cite many factors such as the rapid growth of the world's population, more international travel, increasing resistance to antibiotics, and changes in the breeding ground for such diseases.
What do you mean?
There are many parts of the world where, for example, where animals and people live very closely together. An example of this is in China, where a lot of birds and people, domestic ducks and chickens, live very closely to people, along with pigs, and all these are involved, for example, in the flu cycle, in the flu life cycle. And where you have a huge number of people, and look at what an increase we've had in our population over the globe, where you've got this huge number of people associated with these animals, and you get viruses circulating, this raises the possibility of creating a new virus that can then spread across the globe. And where we see humans changing their behavior, opens the door for a lot of these viruses to emerge and then affect the rest of the globe.
Global warming, pollution, and other environmental problems can lead to similar effects. These emerging diseases, or disease we haven't experienced before, can be quite dangerous.
Scary. Isn't there something we can do about it?
Well, there's a lot going on in the scientific community and the public health community to try to develop approaches to prevent the spread of these diseases. And that's what epidemiologists do. That's what a lot of scientists do. But you know, this is a modern world where we have to get epidemiologists working with laboratory scientists, working with environmental scientists, and people who are ecologists and others, so that we can get a global picture of what the threats are, and also understand, using all of these different disciplines, what the opportunities for prevention are. And it's a great opportunity for any young person who wants to get into science or public health. It's a great opportunity for a career in understanding how we can deal with these problems and learn better ways to prevent them. Scientists can develop vaccines and medicines to help prevent infection and treat the disease, and doctors and government officials can develop ways to prevent and contain the disease.
Yeah, that's right. There's a lot to do, and there'll be a lot more to be done. And young people like yourselves are the ones that are going to have to do it. But I can tell you there's great careers here, it's a lot of fun, and you can do something that really makes a difference.
Yeah, actually, Lassa fever occurs all the way across West Africa, and it's one of the poorest regions of the planet.
How long can this thing be for broadcast again?
No longer than 10 minutes.
But we don't even have the part in there where Dr. Fisherhawk talks about getting her glove torn by the infected monkey.
Or the time Dr. McCormick accidentally sticks his finger while drawing blood from a patient who might have deadly Ebola.
That's right. Cindy, do you think it's even possible for us to combine their entire life experiences into only 10 minutes?
We could always do a miniseries. We should probably check tape 25.
Yeah, there, and I think there's something in scene 10, too.
Yeah, actually, Lassa fever occurs.